Now that we've talked about the executor service in terms of the classes that it uses and other interfaces it's involved with, let's talk about its key methods. And this will give you enough information to be able to do the next programming assignment. The methods we're going to focus on here are the ones that are used to submit tasks for asynchronous execution. And we'll also talk briefly about how they can be used to manage the lifecycle of operations. So the executor service can be used to execute individual tasks. The execute method just gets inherited from executor and executes a runnable. Not really very useful thing to do, but it's there. Much more useful are the submit method, which runs two-way async tasks that return a value by a future using the callable and its return result to get the result. This is by far the most common method, and this is what you'll use in programming assignment 2A. This supports what's called a synchronous future processing model, and all that means is that you get back a future from submit, and typically you submit a bunch of things. You get back a bunch of futures. You typically store them into a list or some other collection, and then you can wait on the completion of those futures synchronously by blocking on them until they're done. Future.get can block until the task that is running asynchronously completes successfully, at which point the result will be returned, which might either be a successful result or an exception if something went wrong. You could also submit one-way tasks that don't return any value, and the main reason for doing that is just to cancel them. You're not getting a result back, you're just having the ability to cancel them because you get a future back in return. You can also execute groups of tasks. There's methods called invoke all and invoke any, and you can give them a collection of callables. And the collections can be passed into invoke all or invoke any, and then as the terms suggest, as we'll talk about in a second, they'll either wait, these calls will either wait till everything's done running or it'll wait till the first one is done running. Make sure that if you use invoke all or invoke any, you don't change the parameters in any way while the calls are running. Chaos and insanity will ensue if you do that. Very bad thing to do. Invoke all gives you back a list of futures containing the results when all the tasks are done. So when you get back the results, it comes back as a list of futures, but all the futures are finished. And the reason why they give a list of futures is to indicate whether something terminated normally or exceptionally. And the way that works is when you call get on a future, if it succeeded, then you'll get the result back. If it failed, you get an exception. So that's why it's a list of futures, even though, as we'll see in a second, invoke all blocks synchronously. Invoke any will return the result of the first task in the collection that completed. And it's useful for concurrent algorithms that just want the first result. So imagine you're searching things in parallel in a database and you just care about having a result. You don't really care which result it is. It will cancel any tasks that haven't completed. So once you get a result back, it cancels everything else. If any other results finish before we cancel them, they're just ignored, and only one result is given back. It's a little bit non-intuitive because invoke all and invoke any both block until they're finished. So you have to remember that they themselves are not asynchronous. The calls that they're invoking on the tasks in the collection are asynchronous, but these calls block until they're done, and that took me a while to get my head around it first. There's also timeout versions of these where you can have timeouts that say, try to invoke all these operations for up to 10 seconds, or see if you can get any result in a minute, or whatever. You can give them a time bound on the amount of time to wait. And if the method didn't time out, then you get the results. If it did time out, then some of the tasks may not have completed. And tasks that are not completed are canceled if the timeout occurs. And for the invoke any method, if the timeout elapses and nothing came back, you get a timeout exception. So that's basically, those are the methods that you use for submitting and invoking things to run. There's also a whole pile of methods that are used to manage the life cycle of an executor service instance as well. And an executor service instance can be in one of three states: running, which is what happens after you start it up by calling it, new fixed thread pool or new cache thread pool or whatnot. Shutting down, which happens after you tell it to shut down gracefully or shut down abruptly. We'll talk about those differences in a second. So shutting down doesn't mean it's shut down, it just means it's shutting down. It's like if you go to a store and they're saying, the store will close in 5 minutes, right? The store isn't closed, but it's going to be closing. Maybe you lock the doors and don't let new people in, but you don't trap the people who are in the store and not let them leave, right? So that's shutting down. And then the final thing we have is terminated, which is what's used once everything is done, once the executor service has in fact shut down. There are two methods that are used here, shutdown and shutdown now. Shutdown performs what's called a graceful shutdown that allows currently running tasks to complete. That's kind of like, the store is closed, but we will let you continue shopping until you're done. But any new tasks will be ignored, which is kind of like saying, the store is closed, we lock the door for coming in, but you can still exit. Shutdown now performs an abrupt shutdown that cancels or attempts to cancel active tasks and doesn't process waiting tasks. So graceful shutdown will also not process waiting tasks, but it won't cancel the active tasks. Yeah, say. Yes, a good analogy would be if you go through the process of hitting the software shutdown button on your computer, it'll shut down. Whereas if you pull the power cord out or take the battery out, that's an abrupt shutdown. It's not quite as abrupt as that because it doesn't cause everything to stop running in your program, but it's not a bad analogy. Shutdown now would be like, if you do not leave the store instantly, we will let dogs out to eat you, or something like that. You can think of, the Hunger Games or something like that, where they're going to have the dogs come and eat you, or Stranger Things, where those weird dog-like creatures come in and eat you. So in that case, the shutdown now method causes active tasks that are running, to be canceled and interrupted. And we'll talk about interruptions later. Interruptions are always handled voluntarily. And that's an important thing to remember. We'll talk about that when we get a little further along. So voluntary means that you can't force another task to shut down, but you can ask it nicely to shut down. Shutdown now, because it's shutting a bunch of stuff down, will return a list of waiting tasks. So if there were tasks that were waiting to run, they will be returned to you, so you could do something with them, or at least know that they didn't get a chance to run. After you've shut down an executor service, then any new task you try to submit will be rejected with the rejected exception handler. You can also silently discard the tasks, so you get a choice of what to do. Here are a couple of methods to check to see what state the executor service is in. We have is shut down, which says, has the shutdown process begun? Like, has shutdown or shutdown now been called? And we'll talk about that. Is terminated and await termination. So this basically just checks to see, are we in the shutting down state? This checks to see whether we are shut down. We are now in the terminated state. Everything's stopped running. And this method can be used to wait for all the tasks it'll wait for all the threads in the thread pool to stop running. And you can bound the amount of time that you might want to do that. If you call shutdown now, that might reduce the amount of time you await for termination, because that'll be more draconian in actually trying to stop those tasks from running. Whereas if you call shutdown, then active tasks get a chance to keep running. I guess the best example is when we take the quiz in a minute and the quiz is done, right? You can either say, quiz is done, you got to wrap up, or you can say, quiz is done, and rip the paper out of your hand, which would be rather rude, but it all depends on how long over the deadline you've gone, I guess, in some sense. You can think of the shutdown methods and the await termination methods as providing a form of what's called barrier synchronization, and we'll talk more about barrier synchronization later. Okay, so that is the end of that.